A rift valley is a linear-shaped lowland between several highlands or mountain ranges created by the action of a geologic rift or fault. A rift valley is formed on a divergent plate boundary, a crustal extension, a spreading apart of the surface, which is subsequently further deepened by the forces of erosion. When the tensional forces were strong enough to cause the plate to split apart, a center block dropped down between the two blocks at its flanks, forming a graben. This drop of the center creates the nearly parallel steeply dipping walls of a rift valley when it is new. This feature is the beginning of the rift valley, but as the process continues, the valley widens, until it becomes a large basin, that fills with sediment from the rift walls and the surrounding area. One of the most well-known examples of this process is the East African Rift. Rifts can occur at all elevations, from the sea floor to plateaus and mountain ranges. They can occur in continental crust or in oceanic crust. Rift valleys are often associated with a number of adjoining subsidiary or coextensive valleys, which are typically considered part of the principal rift valley geologically. The most extensive rift valley is located along the crest of the mid-ocean ridge system and is the result of seafloor spreading. Examples of this type of rift include the Mid-Atlantic Ridge and the East Pacific Rise. Many existing continental rift valleys are the result of a failed arm of a triple junction, although there are two, the East African Rift and the Baikal Rift Zone, which are currently active, as well as a third which may be, the West Antarctic Rift. In these instances, not only the crust, but also entire tectonic plates, are in the process of breaking apart to create new plates. If they continue, continental rifts will eventually become oceanic rifts. Other rift valleys are the result of bends or discontinuities in horizontally moving faults. When these bends or discontinuities are in the same direction as the relative motions along the fault, extension occurs. For example, for a right lateral moving fault, a bend to the right will result in stretching and consequent subsidence in the area of the irregularity. In the view of many geologists today, the Dead Sea lies in a rift which results from a leftward discontinuity in the left lateral moving Dead Sea transform fault. Where a fault breaks into two strands, or two faults run close to each other, crustal extension may also occur between them, as a result of differences in their motions. Both types of fault-caused extension commonly occur on a small scale, producing such features as sag ponds or landslides. Rift Valley lakes. Many of the world's largest lakes are located in rift valleys. Lake Baikal in Siberia, a World Heritage Site, lies in an active rift valley. Baikal is both the deepest lake in the world and, with 20% of all of the liquid freshwater on Earth, has the greatest volume. Lake Tanganyika, second by both measures, is in the Albertine Rift, the westernmost arm of the active East African Rift. Lake Superior in North America, the largest freshwater lake by area, lies in the ancient and dormant mid-continent rift. The largest subglacial lake, Lake Vostok, may also lie in an ancient rift valley. Lake Nipissing and Lake Timiskaming in Ontario and Quebec, Canada lie inside a rift valley called the Ottawa-Bonnechere Graben. Yngvalavatan, Iceland's largest natural lake, is also an example of a rift lake. References: The Ethiopian Rift Valley. Giacomo Corti Sienera, The World's Greatest Lakes. Archived from the original on November 27, 2006. Retrieved January 7, 2007. Lake Baikal, a Euro World Heritage Site. World Heritage. Retrieved January 13, 2007. The Oddities of Lake Baikal. Alaska Science Forum. Retrieved January 7, 2007. Seiget, Martin J. Antarctica's Lake Vostok. American Scientist 87, 510. Bibcode, 1999 AMSI 87510 Estoy, 10.1511/1999.6.510. The best explanation is that Lake Vostok may lie in a rift valley, as does Lake Tanganyika in East Africa and Lake Baikal in Russia. The geography of Lake Vostok is indeed consistent with this notion, in that the lake has a crescent shape, just like Tanganyika and Baikal, and the side walls of the lake are relatively steep, at least on one side. John Grotzinger, Understanding Earth. New York. W. H. Freeman. ISBN A0-7167-7696-0. Further reading, Bonnetti, E. 1985. Punctiform initiation of seafloor spreading in the Red Sea during transition from a continental to an oceanic rift. Nature, 316, 33 €37. Mart, Y, Dotuil, O, 2000. Analog experiments of propagation of oblique rifts. Tectonophysics, 316, 121 €132.